So what we're going to do now is talk about some other internal issues related to parallel streams. And in particular, the topic we were discussing last time was how you could figure out what could be changed and what couldn't be changed with respect to parallel streams mechanisms. So now we're going to talk about splitting, combining, and pooling, and what can be changed and what can't be changed. As with regular good old Java sequential streams, some of the features like splitting and combining and pooling are invisible. In particular, all Java collections come with predefined SplitterAters that can be used to create parallel streams. This, of course, comes courtesy of the collection interface, which everybody implements by default. If you take a close look at the collections interface, you can see that there's a SplitterAter defined, so every built-in collection has a SplitterAter, and there's a parallel stream factory method that uses the stream support.stream method in conjunction with that SplitterAter with the parameter true. And so that's what actually causes a parallel stream to be created using a SplitterAter that will split it in such a way where things get split into chunks, which are then given off to the fork join pool, as we'll talk about in a second. At the other end of the spectrum, at the terminal operations, there are these collector factories that come as part of the collector's utility class. And these collectors can be used to create collector factories, can be used to create collectors that will work properly with parallel streams. What you get with the collector factory methods like toList and toSet are so-called non-concurrent collectors. We've talked about non-concurrent collectors already. Non-concurrent collectors are the ones that work with parallel streams, but they do things by joining together successively larger chunks of sub-results into a final reduced result. And we'll talk more about that shortly. And then the other thing that is typically invisible is the common fork join pool, which is used to run the intermediate operations on the chunks of data that are split by the SplitterAter and combined by the collector. So the common fork join pool is used out of the box. So all those things kind of work without you having to know much of anything about how it behaves. Obviously, we're going to talk about how it behaves, but you don't have to know much about how it behaves in order to get it to work properly. However, if you need to, you can customize all of these mechanisms. So you can define your own SplitterAter. You can either use you can use the SplitterAter. There's an abstract SplitterAter helper class that fills in some of the methods. There's also the SplitterAter interface, which defines a whole bunch of methods for traversing and partitioning the source. The try advanced method, as we've talked about before, is used by both sequential and parallel streams for the part that's the sequential part of the processing. For parallel streams, the try split method is the key one. So try split is what's used to actually split the chunks up into subchunks, which are then split up into subchunks until we kind of bottom out with the recursion. And we'll talk more about how that works in just a second. Again, if you get there into the spectrum, you can create the collector. You can either use the of method that comes with the collector, which is kind of the simple public factory method, or you can just go ahead and implement the collector interface. And we'll take a look at both of those things. Keep in mind that the characteristics method here, this is the method that determines whether or not a collector is a concurrent or non-concurrent collector. And we'll get more experience playing around with concurrent collectors later because they're kind of cool. And then finally, if you don't like the thread pooling mechanisms that come out of the box with the default common fork join pool, there's a couple of ways you can modify the behavior. It's a little bit constrained, as we'll see later, but you can use something called a managed blocker. And a managed blocker can be used to let the framework automatically create new worker threads for the fork join pool, the common fork join pool, which will temporarily expand the number of threads in the pool while the processing is taking place. And then later, when those threads aren't used for some period of time, they can be reaped and returned back to some common idle pool or just removed altogether, thereby making it possible to expand and contract the number of threads, worker threads, that are available in that pool. And we'll talk a lot about that when we talk about fork join pool that comes up a little bit later. Okay, so that was a quick summary of, at a high level, what splitting, combining, and pooling mechanisms are that you can customize in one way or another.